why we have structured programming language, starting with C, right? Later on, Fortran add this as well. But basically to say, okay, for the same piece of code, if you reuse that piece of code many times, define it as function, then you can go to that function, call that function separately many times. Okay? So for us, if we just have a piece of code and jump into that piece of code, you can see that there's going to be trouble here, right? So how to pass parameters, going to be a problem. There's no parameter passing, everything is a global variable, right? The programming that is going to be a pretty big nightmare. And now we have better, starting from C, we already have pretty good programs. Structured programs. All right, interaction diagram, as we mentioned, is to capture the dynamic aspect of our program. This is internal. Okay? Interaction diagrams are internal. Now, when you come to interaction diagram, you have already defined, named your classes, your objects, pretty much. Now you are assigning responsibilities to your classes. Sequence diagram, collaboration diagram are basically for that purpose. How do you come up with sequence diagram? Basically, you take your use cases and separate out the scenarios and actually realize your scenario on top of your class diagram. Okay, if you look at this sequence diagram, it provides you a bunch of information. Number one, this is a use case corresponding to one use case or one scenario in the use case. Okay? You have a user of this use case called buyer. The buyer will send a message to the system. Sending a message is just an abstraction. Can be using manual items, right? Can actually be sending a message over the internet. Up to you to implement this. But hey, they're the one way of communication between your user and your system. In this case, it's a user interface, basically by pushing buttons, manual items, and so forth. And now, if you look at it, first information you got is, guess what? We already have the classes of my system identified. User interface, assemble order, control class, order class, price class. I know these are the classes in my class diagram. And this is just, this diagram, sequence diagram, the third part is how we actually using this set of classes to implement one scenario of this use case. Maybe this use case just have one scenario, then you're done. But this use case may have multiple scenarios, then you may have to have multiple sequence diagrams. Or you can actually put everything about that use case, multiple scenario, in the same sequence diagram, which sequence diagram allow you to do that by allowing branches, essentially. Right? So here, it basically gives you the sequence of action that have to happen between your classes to implement this use case. Again, use case is external view of your system. Sequence diagram is the internal view. Basically, you look at how your component talk to each other to do a job. That job is this use case.
Is that last step 9, actually allowed with the user directly interacting with the order class rather than the user interface class?
You mean this?
Yeah. Or is that just an
Yeah.
abbreviation?
Yeah, that is, so certainly I think in any real design, I think this here need to be, go through the user interface. Okay, you go through user interface anyway. This is just an abbreviation. So that's sequence diagram, right? Then you also have, so similarly you have sequence diagram here, right? So you have more complicated sequence diagram. I mean, sequence diagram by itself actually is governed by international standard. You may say, wow, this is such a simple concept. I mean, why you're making it so complicated? If you look at the International Telecommunication Union, has a 1,000-page definition or standard for this sequence diagram. Okay, I don't think anybody here is willing to spend some quality time with that 1,000 pages of standard.
Does anyone actually read that?
Yes, yes. The people who, I'm sure the people who make the standard actually read it. Whether we read it or not, that's entirely different question. That's my point. Okay? This is an important concept and useful tool, but you don't have to have everything about that sequence diagram understand to actually use this sequence diagram. Okay? For us, this level probably is sufficient now. Okay? We need to know the user, we need to know our classes, we need to know sending a message to each other to realize their communication and action. To realize a scenario of our use case. That's all we need to know. Okay? This probably we can finish this with one single page, not 1,000 pages of documentation. The same thing happens to UML. Yes, good luck. I mean, there are probably several thousand pages of documentation you can dig out. But hey, you don't really need those. Okay? We are basically doing minimum things to get by. You certainly don't want to overdo this. I mean, well, for some time, I mean, about 15, 20 years ago, people are overdoing this. We actually, originally we still have programs like that, but basically people spend a lot of time reading all the documentations in class. Well, that's not, I mean, this sequence diagram can be a whole class, but we are basically spending less than a lecture, maybe 10 minutes to go over it. Because for that, I mean, this is such an easy concept on this level. It's useful and easy. I mean, if you know this, you read this once, I don't think anybody need to teach you one more time about this. You should be able to read this. We also talk about the collaboration diagram. That is, you emphasize the interaction among them, not the sequence information. But these two things are actually totally equivalent. Minus the beautiful placement of your classes. Okay, that is again something that's not necessary, but some cases nice to have, right? You actually place the classes in a nice way, so your diagram is easier to understand, right? But would that render your diagram incorrect? No. I mean, if you move some placement of your objects and the messages, as long as they go to the right place, even if they don't look perfect, I mean, it's still a correct diagram. All right. Another important concept we talked about before, I mean, important. This is actually, you're looking into the system or you're looking into one class internally. Here, we're essentially looking into one system. This is how one system behaves on the top level. You use Statecharts. Statechart is in everything. Your computer is a big state machine itself. Then it shouldn't come as a surprise to you guys. Your program is all your programs are state machines. No exception. No exception. all your programs are state machines because they all run on our computers. Each one of our computers is a state machine. State machine is pretty simple. For in this case, it has a starting point. Say this is when you can say, oh, this is when the computer is not on or the program is not running. You launch a program, it's going to a state, waiting for something to happen. Right. If you turn on your computer, right? If your computer has no program, your processor basically just looking there doing nothing. Doing nothing. Right? So typically, so you actually, right now it's fairly hard to get a computer which has no program loaded. Even if you don't have operating system loaded, you always have BIOS loaded. It's pretty hard to get a computer which not even have BIOS loaded. Okay, your BIOS are always loaded. When you with your motherboard and your chipset, and you always load it. Okay, so if you just have BIOS, you will know your system will come to a point and say, I'm looking for an operating system. Which I'm sure many of you have seen that prompt before, right? I'm looking for an operating system. In that case, your computer is waiting for something. And your program should be doing the same. For instance, your chat app, the front end, your client launched, immediately go here, right? Immediately go here, waiting for something to happen. The first thing that can happen to you in your program should be log in, right? And your program is stronger in that sense. Nothing else can happen before login. If you allow me to send a message even before I log in, well, your program is incorrect. Okay? That's not a matter of good design or bad design. It's actually whether your program is correct or not. But once you log in, other feature is enabled. But your login is not enabled anymore. Your log out is enabled now. Okay? You are actually designing a state machine. State machine means you stay in some state until something happens. This is how our computer works. This is also how our program should work. State machine. All right? So you are not going to escape from state machine. Okay, this is any program you write is a state machine. All right, you have, so certainly more things. I mean, you actually have messages that, for instance, this elevator, when there's no message, it's basically staying here. When there's a message, it's going to a different state. All right. You can actually have aggregation in state machine, which is basically say, okay, you have one big state, make it your state. This is just a syntactic sugar to make your state machine simpler. Okay? So we have covered the critical diagrams, but diagrams are not important. We have covered the critical information you have to have in your project. Okay? Use case diagram. You're looking at your system from outside of the system. User point of view. This is also your sort of contract with your customer. This is where you enumerate the list of functionality you have, features you have for your program. Questions about use case diagram? Okay? You need to figure out who are the users of your program. You need to list the features of your program. You can use use case diagram to list those features. You can use a table to list those features. You can use user stories to list those features. You may write a program to list those features if that you want to do that. Okay? The format is not important, but step one is you need to articulate the set of features. No matter what you do, no matter what computer program you're going to do, you've got to able to list the features. You may say, oh, I'm just going to start writing programs. I mean, yeah, guess what? Even if you start just writing program, you already, by default, have a list of features already. Okay? In your mind, you just didn't articulate, you didn't list it out, but that's not good. Because if you just have nothing to do and just want to write a program, that's probably okay. But if you are creating something you're building on, you want to work on this tomorrow, the day after, in a week, in a month, you've got to put down some kind of documentation. More importantly, if you want to work with a team, you would have to write down this information in some format your teammate can consume. If you agree on user stories, user story card, which is essentially I'm going to articulate with a piece of card. I mean, so we have all used card in our high school days, and we say, okay, write down the thing. We want to memorize and everything, right? The same thing happens in software engineering project. Basically, we have when people put card on the board and say this is a set of features we need to implement in our program, right? You can do that, or you can use a use case diagram, or you really like Excel. Use tables. Use tables. That's fine. But the first step in our software engineering project is to articulate requirement. If you think about our requirement, essentially set of functionality you need to provide from your system. Okay? Then the second step, we are walking into the system. Immediately we're seeing the components of our system. That is class diagrams. We can give them some relationship to record information and simplify our design on our class diagram, associations, aggregations, inheritance, right? That's just static relationships. Say, okay, they may have some kind of relationship together. Okay? That is when we are partitioning our system into components. We're going to deal with those components one by one. Or assign different people to work on different components. All right? Then how do we move to the next step? We actually take use cases and say, this is how we are going to implement each of our use case with a set of objects in my system. How do you identify those classes? You may just say, oh, I got it. That's fine. That's fine. If you have the ability, good for you. If you can just say, oh, I'm just going to look at this and just write down the set of classes, that's fine. If that fails, you know you have some basic thing work to do, some semantic analysis to identify the nouns and attributes and things like that, and verbs. That will generate a set of objects, their name, their attributes, and also the actions they need to take. If that other thing all failed. Okay? If your shortcut didn't serve you well, back off. Just walk the track. All right? Then you can essentially come to your sequence diagram, which you implement your use cases with a set of object classes you already identified. If you implement them all, your design is almost done. The rest is just detailed design assign those attributes to your class, the data type, and also assign the actions, and nail down the signature of those actions, and name or describe the algorithm tabular way, as we mentioned last time, or flowcharts. You have practice in your homework 1, and more importantly, things you always do, pseudocode. If you would like to use code, if you already want to do somebody else's job and provide them with a full code, I think they'll welcome that. But it's not necessary on the design level. Okay? On the design level, you're basically stopping at pseudocode, flowcharts. Okay? You actually may be the person actually implement that flowchart or the pseudocode. Okay? But it's a good way to actually provide that so that somebody else can work on it. I mean, if you work in industry, in some case, you own a module. You work at a module today, tomorrow, I mean, in a week, I mean, maintain that module until you switch to a different job, different project, or that project ended. Or you actually have a more team-oriented approach. Today you work on this module, tomorrow you work on a different module. If that's the case, you better hope the guy who worked on this module yesterday lived everything in a way that you can consume and start working on that module today. If you actually need to spend a day to decipher what he is saying or she is saying and what need to be next, you know what's going to happen, right? You have zero productivity. Okay? The amount of time you should spend on getting your up to speed in a day, I mean, shouldn't due to be beyond 1 hour. Otherwise, you are eating in the productivity of the team. Okay? In that case, each product has to be small enough. At the same time, the documentation should be sufficient. Basically, it's just what is sufficient. You may say, oh, what is sufficient? How much should I write? 2 pages, 3 pages?